We come into contact with many physical quantities in the natural world on a daily basis. Physicists, air traffic controllers, and video game creators all have the same thing in common: vectors. What exactly are they and why do they matter? But first, we need to understand scalars. Scalar is a quantity with magnitude. Its example includes speed, density, time, mass, temperature, and entropy. Vector. A vector is a representation of quantities that have both magnitude and direction at the same time. Its examples include displacement, force, velocity, acceleration, and momentum. Vector quantities are represented by a letter with an arrow head above it and can also be represented graphically by a simple arrow.
Suppose we have two vectors A and B are considered to be parallel if they have the same direction even if they do not have the same magnitude. Anti-parallel if they have opposite directions regardless of their magnitude. Equal if and only if they have the same magnitude and direction. Negative of a vector. A vector having the same magnitude as the original vector but opposite in direction.
Vector addition is the operation of adding two or more vectors together into vector sum. Tail-to-tip method. For two vectors, the vector sum is obtained by drawing the vector from the free tip to the free tail. Parallelogram method. The so-called parallelogram method gives prolific vector addition of two or more vectors.
We can represent any vector lying the x and y planes as the sum of the vector parallel to the x-axis and vector parallel to the y-axis. These two vectors, vector a sub x and vector a sub y, they are called the component vectors of vector A, and their vector sum is equal to vector A. In symbols, vector A is equal to vector a sub x plus vector a sub y, where a sub x be the magnitude of vector a sub x, a sub y be the magnitude of vector a sub y, a be the magnitude of vector a. By applying the Pythagorean theorem, we find the magnitude pi of vector a. A is equal to the square root of a sub x squared plus a sub y squared.
If theta is measured from the positive x-axis and a positive angle is measured toward the y-axis, then theta is equal to the square root of tangent negative 1 times to the absolute value of a sub y over a sub x. If a vector is described by a magnitude a and an angle theta measured from the positive axis toward the positive y-axis, then its components are given a sub x equals a cos theta and a sub y equals a sin theta. If the vector lie on the xy plane, they are divided into their x and y components. Then we calculate the x and y components of the resultant vector by adding the x and y components of the vector to be added.
To solve for the resultant vector of r sub x, vector r sub x equals r sub x I hat, and to solve for the resultant vector of r sub y, vector r sub y equals r sub y j hat. For the magnitude, r equals square root of r sub x squared plus r sub y squared. Theta equals tangent negative 1 times absolute value of r sub y over r sub x.
Unit vector. A unit vector is a vector that has a magnitude of 1 with no unit. In an x to y coordinate system, we can define a unit vector I hat that points in the direction of the positive x-axis, and a unit vector j hat that points in the direction of positive y-axis. Then, we can express the relationship between component vectors and component then. Vector a sub x equal to a sub x I hat, and vector a sub y is equal to a sub y j hat. Similarly, we can write a vector a in terms of its component as vector a is equal to a sub x I hat plus a sub y j hat.
Using unit vectors, we can express the vector r of two vectors a and b as follows. Vector a is equal to a sub x I hat plus a sub y j hat. Vector b is equal to b sub x I hat plus b sub y j hat. Vector r is equal to vector a plus vector b. A sub x plus b sub x I hat plus a sub y plus b sub y j hat is equals to a sub x I hat plus r sub y j hat.
Here is an example. A cross-country skier skis 1 kilometer north and then 2 kilometer east on horizontal snowfield. How far and in what direction is she from the starting point? In a given situation, we need to identify and set up. The problems involves combining two displacements at right angles to each other. In this case, vector addition amounts to solving a right angle, which we can do using the Pythagorean theorem and simple trigonometry. The target variables are the skier's straight line distance and direction from her starting point.
The distance from the starting point to the ending point is equals to the length of the hypotenuse. We're going to use distance formula. Square root of 1 kilometer squared plus 2 kilometers squared is equals to 2.24 kilometer. A little trigonometry allows us to find angle theta. Tan theta is equals to opposite side over adjacent side, where opposite side is 2 kilometer and adjacent side is 1 kilometer. Dividing the opposite side and adjacent side, we'll get 63.4 degree. We can describe the direction as 63.4 degree east or north, or 90 degree minus 63.4 degree is equals to 26.6 degree north of east.